In this video, I'd like to talk about the math question of the day for February 27th, 2023. And for this question, we need to find the length of this diagonal D in this rectangular prism here, and we need to round our answer to the nearest tenth. So to answer a question like this, to find this length across this diagonal here, you need to have a solid understanding of geometry and essentially everything that comes before that. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, let's start working through this together. And if you do have suggestions for future videos, for future questions of the day, feel free to leave those as a comment below. Now, when finding the diagonal of a rectangular prism, you might remember that this is essentially using the Pythagorean theorem in 3 dimensions, where we essentially take the square root of each of these legs, 2 squared plus 7 squared plus 4 squared. And this would give us the answer. But if you don't remember why this is true, then we can break this down into smaller triangles. So let's back up. Let's assume that we don't know the formula or how to use that. And what we can do is draw a diagonal across this bottom rectangular face so that we get this right triangle here. And if we can figure out this length here, then we can use the regular Pythagorean theorem to find D. So we need to find this length of this lower diagonal, and let's just call this some letter. We can call it x. And notice that we have a right triangle right here. That this is a right triangle with legs 4 and 7 and hypotenuse of x. And keep in mind that when we have any right triangle, we can use what's called the Pythagorean theorem, which relates the legs to the hypotenuse. So if this was A, this is B, and this is C, and this is a right triangle, then the relationship between the sides is that A squared plus B squared is equal to C squared. So we know A and B in this case. We can call this A, it doesn't matter, and this B, if we want, we can switch those. But x here, this is our C in the Pythagorean theorem. So let's set up our equation. We have that A squared, 4 squared, plus B squared, which is 7 squared, is equal to C squared, which is x squared. And we can evaluate this and find x, but we actually won't need to because we're going to set up the Pythagorean theorem for this right triangle with the diagonals. So let's do that, and I can show you why we don't actually need to find x. But if you want, you can evaluate this. 16 plus 49 is x squared, and you get 65, and square rooting each side, you get that x is the square root of 65. But we didn't need to do that because when writing the Pythagorean theorem for this triangle, now A and B are x and 2. So we get 2 squared plus x squared is equal to this diagonal squared. We just applied this Pythagorean theorem to this right triangle right there, composed of those diagonals. And notice that we have x squared. So if we want, we can just substitute in what we know is x squared. We have 2 squared plus 4 squared plus 7 squared, since this is just x squared. This is equal to d squared. And to find d, we just take a square root of both sides. We get 2 squared plus 4 squared plus 7 squared. And this is all equal to d. And notice this was that formula that we wrote in the beginning. We're essentially just taking the Pythagorean theorem in 3 dimensions. Now, if you didn't want to do this substitution, you can find x. X is the square root of 65. And when you square that, you will just get 65. Which makes sense because this right here is equal to 65. So let's actually carry this out. This is 4. So we have that d is the square root of 4 here. And we know this is 65. So 4 plus 65. So we get the square root of 69, which we need to round to the nearest tenth. And after putting this into a calculator, we can find that our diagonal is approximately 8.3066. So we can just round it to 8.3. So this right here should be our final answer.